Okay, here we're working with complex numbers. Now, standard form of a complex number will look like A plus BI. And what we're saying is that A is our real part, and then this is our imaginary part. So if you think of it as the complex number plane, we have an imaginary axis, and then we have a real axis. And so real numbers really have 0 for a B value, and they are on that real axis. When we get into the imaginary part is now when we have that other portion. Now, what we need to be able to do is we need to be able to, first of all, add and subtract these complex numbers. So look at a couple of examples here. If I have the complex number 7 plus 3i plus the complex number 5 minus 4i, as far as adding that, well, I'm going to add my real parts, 7 and 5, and then I'm going to add my imaginary parts. We have plus 3i minus 4i, so that would be a plus and negative 1i. As far as simplifying that, we could write it as 12 minus I. For subtracting complex numbers, I have 3 plus 4i minus 5 minus 3i. Again, I would now take the 3 minus 5, that's a negative 2, and then I have 4i minus a negative, so that turn that to plus. 4 minus a negative 3i is 4 plus 3i, that's going to be a plus 7i. Now we also need to be able to multiply. Multiplying complex numbers. A couple different examples here as well. If I have 2 minus I as my first number times 4 plus 3i, I could almost think of this like FOIL, or I can take 2 times this quantity of 4 plus 3i, and then I have the minus I times the quantity of 4 plus 3i. Again, it's almost like we're doing FOIL here, where I'm going to do first outside, inside, last. What this gives me is 8 plus 6i minus 4i, and then this is a minus 3i squared. Now, one thing to note is that I squared is equal to negative 1. Because remember, where the imaginary piece really comes from, what we're saying is that I is equal to the square root of negative 1. So if I have I squared, then that is equal to negative 1. So anytime we have an I squared, we plug in the negative 1. And then I'm combining my real parts again. And so now this negative 3i squared, that's negative 3 times negative 1, that becomes plus 3. So now I have my 8 from here and then a plus 3 here. And then I have my imaginary parts. That would be the plus 6i and the minus 4i. So now I'm basically combining like terms. I have 8 plus 3, that's 11. And then the plus 6i minus 4i goes to plus 2i. And if we have a quantity squared, let's say I'm squaring my complex number of 4 plus 2i. Again, we can think of that as 4 plus 2i, 4 plus 2i, where I FOIL that, or again, I could separate it as we did the one above. So what I have is 4 times a quantity of 4 plus 2i, plus 2i times a quantity of 4 plus 2i. That gives us 16 plus 8i plus 8i plus 4i squared. Again, the I squared equals negative 1. That turns that into a negative 4. So now we have 16 minus 4, and then we have plus 8i and plus 8i, which gives us 12 plus 16i. Now what we also are looking at in section 2.4 is the conjugates, complex conjugates. So, for example, we said a plus bi is our complex number in standard form. The conjugate would be a minus bi. So, when we're multiplying conjugates, if I have a complex number 4 minus 3i, and its conjugate, which would be 4 plus 3i, it's like difference of squares. What we have is 4 times 4 is 16. The outside and the inside cancels each other out. We have a negative 3i and a plus 3i. That turns into minus 9i squared. I squared is negative 1, so that turns that into 16 plus 9, which is 25. So we can use that then if we're looking at the quotient of complex numbers in standard form. Now what that means is that we're going to simplify this. We're going to try and write our answer in standard form, and what we basically want to do is get rid of any imaginary or complex numbers that are on the bottom of a fraction. So if we're asked to write in standard form, that means a plus bi, and we have 2 plus I divided by 2 minus I. What I am going to do here is I'm going to multiply, take that number, and I'm going to multiply top and bottom of this fraction by the conjugate of the denominator. So in this case, that'd be 2 plus I. And the idea is that, just like we showed above, when you're multiplying conjugates, it is like difference of squares. And so what we end up with is 4 and then minus I squared. So that's 4 minus a negative 1, or 4 plus 1. That equals 5. So now we have a real number on the bottom of our fraction. I do need to multiply this out on top. I have 4. If I treat it like FOIL, that's a plus 2i, and a plus 2i, that's plus 4i. And then I have I times I, so that's a plus I squared. That again is a negative 1, so that turns into 3 plus 4i. Now, we're not done yet, because to write in standard form, I'm going to separate this into my two parts. I have my real part, that's the 3 over 5, and then I have my imaginary part, and that is the 4 over 5i. And that would be in standard form. And if I have a square root of a negative 14, and we're multiplying that by the square root of negative 2, and we're going to write this in standard form. Okay, first of all, we already said that square root of a negative 1 is our I value. So I can rewrite this as a square root of 14i. And then rewriting this, that's a square root of 2i. Now as far as multiplying those, I have a square root of 14 times a square root of 2. That would simplify to 2 square root 7. And then we have the I times I, that's I squared. And so that's our -1, so our answer is -2 square root 7. And then our last example, some of our quadratics end up with complex numbers as our zeros. So if I have something like 8x squared plus 14x plus 9 equals 0, I can then use a quadratic formula. Remember, the quadratic formula is the opposite of b, plus or minus square root of b squared minus 4ac all over 2a. So in this case, I have an a value of 8, a b value of 14, a c value of 9. So that means x is equal to -14 plus or minus square root of 14 squared minus 4 times 8 times 9 all over 2 times 8. So -14 plus or minus, that's going to be the square root of a -92 all over 16. Now, as far as simplifying the square root of -92 and writing that in simple radical form, my favorite method is doing repeated division. I'm basically doing the prime factorization. Divide by 2, that gives me 46. Divide by 2, that's 23. There's my prime factorization. The pair is what comes out. So what that means is that for this, I have -14 plus or minus. So I have 2 square root 23, and that negative is the I part, and that's all over 16. Now all of these are divisible by 2, so x is equal to -7 plus or minus square root of 23 all over 8. Still have our I there. And if we're going to write this into standard form, again, we're going to separate our real part and our imaginary part. So we have -7/8 is our our real part, and then we're going to take plus or minus square root of 23 over 8